Hello and welcome to Phonetics. This is for Bridgewater State University, and of course anyone is welcome to view this video. So we're going to speak about respiration, phonation, and articulation within the context of phonetics. So we'll explain how the three systems connect and how they synchronize their functions so that you can produce phonemes or sounds. So first, the respiratory system has basically basic biological functions to enable us to survive. And we know that the value of it is to enable us to exchange gases with the environment, where we take in oxygen and then release carbon dioxide. So as it relates to speech, when we inhale, we fill up our lungs with air, and as we exhale, we use the exhalation to produce speech. So in summary, the lungs enable us to have the energy, the air that enables us to build pressure, air pressure, and that air pressure from the lungs will enable us to vibrate the vocal folds. The vocal folds are like this when you are breathing. When you are breathing, and you start to switch to speech mode, they are going to shut down the speech. They are going to shut down the airway. So they valve the airway like this. And in order to enable them to vibrate, when they vibrate, imagine again, this is the vocal folds this way, connected in the front, they have their origin, and in back they insert onto arytenoids. You should have this information from your AMP. This is a very, very quick review. So you adduct the vocal folds to close the airway. And then the pressure beneath the vocal folds is going to make the vocal folds vibrate. Sends the middle parts of them away, and then the elastic force from the vocal folds, the elastic tissue of the vocal folds, is going to bring them back again to the midline. So constantly it's a struggle between air pressure and the elastic force of the vocal folds that enables the vocal folds to vibrate, to make a vibratory cycle. So again, the respiratory system provides us with the air necessary to generate a buzz in the larynx through the vocal folds. And once that buzz is generated, then it is going to travel through the vocal tract. And in the vocal tract, we have organs of speech that are basically going to chop this buzz, making it from into la 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 da 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 sa, and you make all kinds of sounds, shaping that buzz into individual phonemes, and then words and sentences and so on. So this is how all of them relate. So the laryngeal system, or the phonatory system, does not articulate speech. It doesn't produce speech. It just produces a buzz, which is a raw material for speech. And then the articulatory system has these organs of speech come in contact with each other, and then they shape that buzz into phonemes, and that is the articulation component. And the three of them have to depend on each other. Looking at the respiratory system quickly in terms of anatomy and physiology, it consists of the thorax, of course, and inside of the thorax you have the lungs. Under the lungs you have the diaphragm. And in order to expand the lungs to get the air in, you have to elevate the thorax. And in the process of doing so, you are expanding it forward, backwards, like anterior, posterior expansion, and also you expand it like horizontally. And they use the diaphragm to expand the thorax and the lungs vertically. So when the diaphragm contracts, it's going to go down, to be flattened and goes down. And that expands then the lungs in a three-dimensional manner. So you can see here are the ribs, and then the sternum, manubrium, body, xiphoid process, and in the back you have the vertebral column. And out of each vertebra you have two ribs coming, one on the right, one on the left. So you have 12 on the right, 12 on the left, my right, my left. And then you have in the front, you have the cartilage segments that come on top. They are smaller and they become bigger and bigger as you go down. Cartilage is what enables the thorax to expand. And you notice that in the lower part of the thorax, you have the greatest expansion because there is more cartilage in these areas. So there are, when we look at breathing in terms of the time it takes, we have vegetative breathing and we have breathing for speech. Breathing for speech is effort. So you are going to use a lot of muscles. Vegetative breathing is mainly performed using the diaphragm. So in terms of looking at the breath cycle itself, for example, for vegetative breathing, you are going to have two parts of the cycle, inhale and an exhale. So the inhalation part takes about 40%. That is if you are resting, if you are not exerting effort, not, for example, speaking. And when you exhale, it takes about 50%. And the exhalation could go from 50 to 60%. So anywhere like 40, 45 for inhalation, then you have 50 or 55 to 60 for exhalation. So the idea of this is the two parts of the cycle, the respiratory cycle, the two parts, inhalation, exhalation, are fairly close to each other in terms of time. We use the diaphragm as the primary muscle in order to expand the thorax down. When you expand it down, the lungs are expanded and pulled down, and that creates more space. And there's minimal involvement of the accessory muscles of inhalation. However, when you shift to breathing for speech, that is effort. And the cycle is different. For example, inhalation takes 10% of the cycle, while exhalation takes 90% of the cycle. So, exhalation, in terms of breathing for speech generally, exhalation lasts about 90% of the cycle is spent in exhalation. And the reason is, as the air is going out, then the vocal folds are shutting the airway and slowing down to a great extent. They are slowing down the escape of the air. So that slows down the cycle, which means that it goes to up to 90%. And that also requires heavy involvement of the accessory muscles of inhalation and exhalation. Now, moving on to the phonatory system, the primary function functions of the larynx are number one, airway protection, to provide a valve so that materials wouldn't go down into the trachea and into the lungs. And then also it enables you to build pressure, because when you adduct the vocal folds, then you trap the air beneath, and the air pressure is going to build up, and that is going to, of course, contribute to speech. So the secondary function basically is phonation, which is a secondary function, obviously, because we can physically survive without having to speak, even though it will be very, very difficult. But speech is called an overlaid function because we have a system that already, or these systems, you already use them for survival and for other purposes. But now we use them for phonation as well. And since we have that and we adapt them for phonation purposes, now they become called, we call them like an overlaid function. So here is the larynx, is an anterior view. You see the thyroid notch, you can touch it here. It's like that little V here. Everyone has it. And if you go below the thyroid notch a little bit from inside, you are going to find the origin of the vocal folds. One starts here, one starts there. And each vocal fold, so here is one, each vocal fold is going to go posteriorly, and it will insert onto a muscular process of one arytenoid. So when the arytenoid is rotated to one side, then the vocal folds will be also taken away with it. So you can see the arytenoids here. Each one at the muscular process has a vocal folds attached. So the phonatory system mostly is made out of cartilage, except for a single bone, which is the hyoid bone. And the vocal folds are, this is the abducted position. This is the anterior, this is the posterior. And anteriorly, they originated from the same area I explained. Posteriorly, each one is inserted onto the muscular process of one arytenoid. These are the arytenoids. One is here, but they have a muscular process that I showed you. So, and this is for speech or for holding your breath. So the muscle that actually makes the vocal folds, where is it? Sorry. The muscle that makes the actual bulk of the vocal fold, that muscle is called the thyrovocalis. Thyro because it originates on the thyroid, and vocalis, it means it specializes in vocalization. And then next to it, there's another muscle on the other side called thyromuscularis. And both of these, the thyrovocalis and the muscularis together, they make up one vocal fold. So let's try now. When the vocal folds are open like this, breathing mode, they can never ever vibrate. To vibrate, you have to adduct them, bring them close, making them touching each other with nothing in between that blocks their closure. And then the the subglottic pressure builds up beneath, and then you have these areas here in the middle that are blown apart by the air, and the air just pushes them away, and the air goes out, and then elasticity of the vocal folds will try to bring them back to the midline. And that's a constant struggle, so that by the time the vocal folds come to the midline again at the rest area, then the air pressure builds up, and when they are close to each other, it builds up enough to blow them apart and to generate the buzz. So that happens for females, adult females, about 225, 215 times per second. That means the vocal folds constantly, closing and opening 200, 215 to 225 or so per second. And that is, for males, it's about half that, 100 or 115. So any sound that is produced with the vocal folds vibrating we call that sound voiced. And the sound that is not produced by the vocal fold vibration, we call it voiceless. And we speak about consonants particularly. Why we don't mention vowels? Vowels are all voiced. So let's see. If you put your index finger and your thumb on your larynx and say s, s, do you feel any vibration? Absolutely no. Do the same. S, s, s. Once you switch midstream, you're going to notice and you will feel the buzzing. The vocal folds are making a tone, which means that sound is voiced. So we have voiceless consonants that are produced they are produced without vocal fold vibration, and voiced consonants, they are produced with vocal fold, voiced consonants are produced with vocal fold vibration in addition to noise in the oral tract. Like when I say s, sh, f, all of these are voiceless sounds produced in the vocal tract, in the anterior vocal tract with, all pressure here, but that is noise. So we call it voiceless. And if you have the vocal folds engaged in the process, then this sound becomes voiced. Voiced consonants, for example, b, d, g, v, v, and all vowels are definitely voiced. So the vocal tract is the system for articulation, and it consists of the pharyngeal cavity, the nasal cavity, and the oral cavity. So you have a tube, vertical tube, that's the pharynx, and then the oral cavity, and then the nasal cavity. The articulators, or organs of speech, include the lips, the teeth, alveolar ridge, tongue, hard palate, soft palate, or velum, and also the mandible and the cheeks. These are the articulators, or the organs of speech. So now we're going to look at the different anatomical structures. And we'll see how we can name every sound based on where it is produced and the vocal tract. So when we describe sounds in terms of voiced, voiceless, we only focus on consonants, because in consonants there are two groups. One is voiceless, completely no vocal fold vibration, and a group of consonants that is voiced. That means you have both vocal fold vibration and noise from the oral cavity or somewhere along the vocal tract. So we look at placement of articulation, and we are going to understand why certain groups of sounds are named the way that they are named. So first, if we make a sound with the lower lip coming in contact with the upper front incisors, that sound could be f or v. So both of these sounds are called labiodental. So labio, one lip is involved, and then dental, basically the teeth, labiodental. So I am going to describe the sound f and v as labiodental consonants. What if a sound involves the two lips? I use the two lips to make a sound. So bi means two. Bilabial. It's a sound that uses two lips or is produced by two lips. So what sounds can you think about that are bilabial? I know you know the m, and then p, b, and there's also the w. W is a consonant, So when you say w, you round your lips and push them forward. Then we have a landmark that is a very important landmark, and that is behind the upper front teeth, behind the upper incisors, and that like the gum line go a little bit up above it, you are going to reach the alveolar ridge. The alveolar ridge, which is right here, above the end or the root of the incisors, will be here. So what sounds can we make that are produced at the alveolar ridge? Basically, you can do this by bringing the tongue tip up and having it rest, push against the alveolar ridge. I'll tell you the sounds. Say, as in night, night. And say, t, as in Tim, and d. These are all alveolar sounds. S, z. So all of these are alveolar sounds. Then we have an area right behind and above the alveolar ridge. We describe this area of the hard palate. We describe it as post-alveolar, like in terms of the sounds that are made there, we call them post-alveolar. Or sometimes we call them palatal, because that is at the very borderline between the palate and the alveolar ridge. And then the palatal or velar, yeah. So all of these sounds are alveolar sounds. And if you go up a little bit, you can try this. Say sh, sh. Once as you say sh, and you're going to notice that your tongue is going to slip up higher and it's going to be starting at the beginning of the hard palate, between the hard palate and the beginning of the alveolar ridge. So this is why this has more than one name. The sounds, that are produced at that area of the palate. These sounds are called the either post-alveolar consonants or or simply they're called palatal. So we tend to just call them palatal. For example, is a palatal sound, and we have sh and zh, palatal, and we have the ch and j. Then palatal sounds, velar sounds, we have the k, g, and as in king. So the tongue, again, can come next to the palate. Sometimes you might find the term lingua palatal, but we try to make things, easier. And then you say lingua alveolar, also, that is also a term. But the best way is to say this sound is alveolar, this sound is palatal, and the other ones, they don't have much variation. Then we go down, there are no other sounds in these areas except for the as in ka-en. So it shuts the airway basically by slamming the vocal folds shut, but there's no vibration. Hit and go back. And so that's the glottal stop produced in the space between the vocal folds. And then we have the sound also at the glottis, which is the ha, as in he. So that also is a glottal sound. And this is described here. Don't want to go back and, I explained it using the picture. And these are, again, the sounds that I have mentioned. And with the teeth and the alveolar ridge, the contact between the tongue and teeth and alveolar ridge. So I don't need to get, more, repeat myself. So here it would be the alveolar ridge, and then this hard palate begins right after. Now, velopharyngeal closure. The velopharyngeal port is the space between the velum and the posterior pharyngeal wall. So here. So the posterior pharyngeal wall is here, and then the velum is here. That space where the air goes from the vocal tract, the pharynx goes up into the nasal cavity. So that area here is called the velopharyngeal port. All English sounds are oral by nature except for the nasal sounds. And all the other sounds require that the velum be lifted up and make a seal against the posterior pharyngeal wall. So here's the posterior pharyngeal wall, and this is the velum. As the velum rises, you have the posterior pharyngeal wall is going to go push forward at an area called Passavant's ridge. And it pushes forward, and then the velum comes in contact with that at the level where the adenoids are, and then closes, and then it directs the air to the oral cavity. So right here, the air will go to the oral cavity. And this is, by the way, the adenoids. So the velopharyngeal port closes when you say all sounds in English except for the three nasal sounds, and then 40 sounds are all produced in the vocal tract. Using the oral cavity. This shows you the dynamics during swallowing. I know this is not about swallowing, but just to show you, this is how the velum seals against the alveolar, against the adenoid pad, and it squeezes the bolus down, and then the velum is swallowed basically with whatever you are swallowing, and then that closes the airway, and it makes the dynamics of the airflow different. But this is the purpose. I wanted you to see how the velum is in closed mode. So you need it up also when you swallow. When someone is unable to activate or to move the velum appropriately because of behavioral issues, for example, someone has a difficulty closing the velopharyngeal port. Maybe the velum is down for some reason when it is not supposed to be. So that could be could happen without any changes to the anatomy. So the anatomy looks normal, but the person somehow isn't able to use that anatomy normally. So that becomes velopharyngeal incompetence. It means inability to use something that you already have. And then we have velopharyngeal insufficiency. The structures of the the closure is not happening because of abnormality in the anatomy. So, for example, cleft palate, there's not enough tissue to close, and then there's a cleft and the air is leaking all over. So we call this velopharyngeal insufficiency. It means the structure is doesn't have a normal anatomy, so it can shut down and seal. So we have situations, for example, when the velopharyngeal port is not fully closed, which means that the velum is not, the velum is lowered, then the air leaks out and the person will make oral sounds, they will have a nasal quality. So like, hi, I see you, how you doing? So the velum is down, the air is escaping, and you have hypernasality. Then if the adenoid pad here is enlarged, and it extends sometimes as big as a little golf ball. So if it's enlarged here, that is going to narrow down the velopharyngeal port, and it will affect see that area here? It will affect the eustachian tube, ventilation, and so on. So in that case, when there is excessive closure or the adenoids are enlarged, and then the velum cannot close, cannot lift to close well there, that is going to cause hyponasality. Not enough air going through the vocal tract, the nasal cavity, because there is blockage by the adenoids. So that gives you the feeling that they speak like they have a cold. And so, for example, you say, mom. They can't say the it becomes bob, how are you? So, then for cleft palate, of course, I'm going to show you here, where you have the hard palate structure, for example, might not be closed off. Like this shelf of bone is not there to close against, to fuse with this shelf. So all of this will be missing because the hard palate fuses in the front and like a zipper, and then as you go back, it closes and closes and closes. So that could also be completed, but in the back here, the velum itself, the tissue is not enough, to close the two sides, and then you have a cleft, a split palate in the back, and the air goes out and leaks out of it. So there's hypernasality is the major problem, and also difficulty producing speech, and also swallowing. So, because swallowing, you need to seal the upper airway completely, and then they produce peristalsis that will propel the whatever you are eating, to send it down. So here are situations. Of course, this is unilateral cleft lip and palate. This is bilateral, and this is unilateral. But bigger, and this one is bilateral. So you could see here the roof of the mouth, basically there is nothing there, but you needed this shelf to grow medially and this shelf and fuse, and this is not happening the same way here. So the tongue is the major speech articulator, and it can come between the teeth to produce th and the. So this way you can call these sounds, th and the, lingua dental, th and the only two in English. You can put the tongue against the alveolar ridge to make these 5 alveolar sounds, n, s, z, t, d, l. And you can bring the tongue tip close to like at the beginning of the hard palate. And that's going to give you the palatal sounds, sh, j, j, and ch, as in chair. And then the tongue also interacts with the velum to produce the ng and the k and g. And so the posterior part of the tongue lifts up and the velum lowers so that they meet and make these sounds together. They sometimes might be called lingua velar or simply just velar. Make your life easier. So that's it for this class. And then next week we'll be working on vowels, and we'll study every vowel and see the transcription of words that involve these vowels. So thank you, and please text me any questions you might have.